Okay. Now we are going to do. Where's my marker? My marker is there. Before we do force, we are now going to do something. What I mean, the graph velocity time. Okay, the graph velocity time. Velocity time graph. So this is our physics class, and in our today class we're going to start with velocity time graph, and then we're going to move to forces. So velocity time graph, when you do, if it is asked in leaving certificate, in the exam, if you do it well, it will enable you to get the distance traveled. Okay, it will enable you to it will enable you to calculate the distance traveled by a body. Okay, for example, I'm going to give you here a question. So let's see, I got to do like that. We have the graph. Here we put velocity in meter per second, and here we put time in second. And for example, if a body traveling from 0, so during, I give you just an example, during the first 3 seconds, it's traveling like that in acceleration, in a certain, so it's like that. It's moved from 0, so from 3, and here if I put, for example, so traveling from 0 at a velocity of 0 till reaching 5 meters or 50 meters per second. 50 meters per second. Okay? And then it keeps that velocity for maybe 10 seconds. Or, no, I repeat. So when it's traveling, get a body, a car, traveling during the first 30 minutes. From the first 30 minutes, going from 0 to 50 meters per second. And then after that, it's going to keep that velocity maybe for 10 or 20 minutes again. For 20 minutes again, put there. And then it's going to decelerate. The velocity is going to decrease the speed for maybe 10 minutes again. Now, if we are asked to get the distance traveled from this time, what we do, we use this, what's the shape of what we have here. This is like mathematics. We have like that, we can divide, it's like that. Okay, here we see that we have a triangle. We get the area of the triangle. And then this, we see that the shape is a rectangle. We get the area of the rectangle. And the other side, this is also another triangle. We get the area of the triangle. in the usual way that we need to know the area of a triangle. Area is half multiplied by base multiplied by the height. Okay, so this is the height, this is the base. Okay, so the distance here is the base, is the height. You multiply, you get the area. Here you do the same, you get the area. And here you multiply the length by the width, you get the area. If you sum them, then you get the distance traveled. So let us do an example. We have a question here that was in Living Cert in 2016. They say a sprinter, okay, write down the question. A sprinter starts I'm going to put it on the question on the board. A sprinter start from rest and accelerate uniformly for 3 seconds until she reaches a velocity of 10 meters per second. She then runs at a constant velocity for 6 seconds before decelerating. This question, sketch a velocity time of her motion. And then calculate the distance traveled. The total distance traveled. The total distance traveled. So in Living Certificate, the question was just sketch a velocity time graph of her motion. So they just stopped there. It is myself that added here and calculated the total distance traveled. So we have a question like that. Now we are going to draw so okay, take down the question first.
I'm done. Taken.
Okay, did you take it? Huh? Before you go to here.
Does the graph have to be drawn on graph paper?
Yes,
Or
yes, accurately. But I think in the exam context they give you a space of where to do it. But it has to be on graph paper, you get it right. So we have here, over there we put velocity. Velocity is meter per second. Velocity in meter, it will be in meter per second. And here will be time in second. So they said for the first 3 seconds, so the first 3 seconds, if we do from here to there, here to there, the first 3 seconds, for example, I put here 3 seconds. Okay, I put 3 seconds here. 3 seconds. Okay, 3 seconds I put there. And then they say until she reached a velocity of 10 meters per second. If I put here I put 10 meters per second, I put there. And
if it was an exam, do I have to put all the numbers or just the numbers I need?
When you do using the graph paper, it will enable you to label, to graduate all the numbers. Okay? But
if I don't put the other numbers, will I lose
But
marks?
because the scale has to be correct.
You
understand? The scale has to be correct. Now,
okay.
Now they say she then runs at a constant velocity for 6 seconds before decelerating. So she gets for...
That means 9 seconds?
So 6 seconds. So that means from here to there will be 9. If I put, for example, 9 there, I put 9, and then let me put this 3. I put here 9, put 9 there, and then they say before for 6 seconds before decelerating. So the deceleration. Now look. We do like that, and this will be so I do it like that. I'm going to join. So enter here. Okay. Now decelerating, maybe we put like that. Okay. Now in the question they didn't say how long is decelerate.
Yeah, I was going to ask that.
Okay, yeah, because as I said, it is myself who add the last part. In the exam, it was just to stop there. But me, I ask. Now, if then we say velocity before decelerating, maybe for 4 more seconds. Okay, you understand? If you can add just before decelerating for 4 more seconds. Okay, just add here like that. Before decelerating for 4 more seconds. For decelerating for 4 more seconds. Okay, just put like that. Okay.
So would it be like 11 seconds on the bottom?
Yes, so 4 more seconds. So it will be 4 more is so it will be 13. It will be 13 here.
Oh yeah, 13. Yeah.
13 seconds. Now, we see, now we have the graph. We have the graph. So I repeat the question. A sprinter starts from rest and decelerate uniformly for 3 seconds until she reaches a velocity of 10 meters per second. She then runs at a constant velocity for 6 seconds before decelerating for 4 more seconds.
Yeah.
Stop. Then sketch a velocity time graph of her motion and then calculate the total distance traveled. Now, I said that the question was asked in Living Certificate 2016, but I modified it here. Here is modified. Now, we have the graph that we did here. This is time in second. So here to there is 10 meters per second. So okay, 10 meters per second. Now we have the graph. To calculate the area, to calculate the distance traveled, the total distance traveled, as I already said, we need to get the area. We get the area of this part. You see this. Let me call this area 1, 2, and 3. So the area 1, how to get it? This is a triangle. So area 1, the triangle is half 0.5 multiplied by the base is 3, multiplied by the height is 10.
What's 0.5 again?
So the formula says half multiplied by base multiplied by the height. The formula of the area.
Alright.
Okay? So half multiplied by base multiplied by the height. Now, half multiplied by base What is the base? Base is 3. Multiplied by the height. Height is 10. Okay? If I
10
multiply...
seconds. Is the height 10 seconds?
No. The height here was a meter per second. We are going to calculate the area. Don't use the unit here. Okay?
Okay.
Don't use the unit. So, 3 multiplied by the height. 3 multiplied by 3 is the base, multiplied by the height is 10. So 30 divided by 2 is 15. Okay?
And what's the unit?
So the 15 now is that the distance in meter.
Okay.
Okay? 15 meter, because we are looking for the distance traveled.
Mm-hmm.
Okay? Meter. The area 2. The area 2 is a rectangle. The rectangle is length multiplied by the width. What is the length here?
6.
6. Yes. So area 2 will be 6. So here to there is 6. So 9 take away 3 is 6. 6 multiplied by 10. Okay? 6 multiplied by 10. We give what? 60 meters.
Would you say that the height of the triangle and then the width of the rectangle will always be the same?
Yes, we can see it here.
Okay.
Can see it.
That's for all questions or just this question?
Yeah, in this question, depending on
Okay.
but if you take this question, you can see it. Your graph will show you anything.
Alright.
Now, and the last part, so the area of the last part will be, so the base, so, half, because it's a triangle, this is a triangle, okay, triangle, half multiplied by the base. Base is what? Is 4.
4.
4, and the height is 10. So
Yes.
if we multiply, we get what? 20. We get 20. Now the total distance traveled will be 15 plus 60 plus 20. That make what? 95 meter.
Okay.
Okay? 95 meters. Now, okay, did you understand?
Yeah.
Okay, let us get another question like that.
Okay.